welcome back. So today is finally Friday and I'm off work. So for this video, I'm going to talk about mostly things that are in the exam. But I will not just do all the problems in the exam because there are also some problems that we didn't learn with our professor this term, so I couldn't be able to solve them as well. For example, um, I think this one was too hard for me. Yeah, this one is too hard for me. Um, yeah, but I'll try to solve which the questions that I can do it. So for the first one, we're going to look at this kind of flow rate. So in the processing plan, the turpentine is piped from the tanks to cans, and that are to be sealed and sold to retail outlets. So these are not really important information. And then we will move on to there are 60 meters of 30 centimeter diameter. So uh, the diameter that is 30 centimeter is around 60 meters long, and for the 20 centimeter diameter it will be 22 meters long. So there are also elbows that are making the water flowing in a different direction. And we also have it says that the the things are made of iron, and we need to determine the pressure drop. I think I've talked about this in the previous video, but I cannot remember. So now we need to know, okay, so we know the volume rate is 0.05, and the given things are the density, viscosity, and the epsilon, which is the wall roughness. So we also have the K entrance. The coefficient of the entrance is around here. So when the water is flowing this way, it loses something because it's it's the coefficient of the input. And then we have gate valve, which also has another coefficient. Globe, globe valve I could not see in this one, so I would say this is just additional information that we don't need. Contraction from 30 centimeter to 20 centimeter is around here, because I would say it's around here, but I highlighted here. Yeah, it's around here. It's also called the sudden enlargement. Yeah, and then we have the 90 degrees elbow and the 45 degrees elbow as well as this one gate is over here, and these are the elbows, and this thing here is the yeah the 45 degrees elbow. Okay, so before I could start doing this, I just want to show some familiar exercises regarding this one. Hmm, Let me start from sketching a diagram. So this is, we can say it's tank number 1, and the water is flowing this way, and then it suddenly enlarged for a moment, and then it's going like a smaller diameter. So this is called the inlet. This is called the sudden expansion, as I have mentioned earlier. Sudden expansion. This is called the sudden enlargement. Yeah, this is also sudden. And then it starts to bend with this and with this. The bend, this is also called the bend as well. So if it's coming here and then there's like something like this, it's called the valve. It has the globe valve and other valve, but yeah, we only need to know like what kind of valve they're telling us in the exercise, and this is called the exit. Okay, so now we know all the things that are we need to consider all of these. It's basically, it's called the minor losses, and it is normally categorized into 6 main parts. We have exit from pipe to tank. We have entry to a pipe from a tank. Then we have sudden enlargement. I'm sorry if my sound is a little bit boring this video, because yeah, as you can see on the screen, it's already 11:20. Sudden contraction in the pipe. Bends in the pipe. Finally, it's called other sources of restriction. So we can say they are pipe fittings and walls. So these are the main points that we need to consider as categorized as the minor loss, because other things, it can be the major losses. So we can say that there are two formulas to consider these. For the minor head loss, we have this formula, Ku squared over 2G. And for the minor pressure loss, equals to 1 over 2 K density U squared. U is the velocity. So it actually can also written as R. Some people would write it as K, but let's just go with K. We can see mostly say it as like this one, right? So K here equals to 8K. Yeah, that's why I think that's why they use R mostly in other things. But you can stick with K, you know. Pi square d4. So this generally comes from HL equals to KU squared over 2, right? And then we can substitute U, which is U equals to Q over A. So it becomes, oh no, there's no equal. So it becomes Q squared over 2A squared, right? And then we can put it as, because pipes are always circle, so it's 4 times 2. So what's in the bottom? So we can do it as this one, Q squared, and A is pi d square over 4, right? Okay, so now we have pi squared d4. So we can write it as RQ squared. Okay, so then we can this is called the minor loss that is expressed in terms of the fluid resistance. So R is called the fluid's resistance. As in electricity, there's also fluid. Fluid. No, there's no fluid in electricity. In electricity, there's also resistance. So when fluid works, there's also resistance as well, like in the pipe, in the flow, and anything else. You can find those kind of resistance that occurs, unless it says that resistance is negligible. So fluid resistance. And then there's another part, because this is only for the HL, right? So we can write for the P, which is the pressure L, pressure loss, pressure L, K equals to, you can substitute that in, rho G Q square over pi squared D4. And then we can write it as R Q squared. Then this R is equal to 8K rho G over pi squared D4. You can see that there's the difference, right? But don't worry. We can separate it as the head loss and the pressure loss. Okay, so now we can start looking at sample exercises before we actually do our exam. I'm trying to find the exercise that has the what do we call that? Like the most close. Yeah, the process are close to our exam exercise. We have the sudden enlargement and sudden contraction. It's quite different for the K, but normally the formula is the same. So in this exercise, it says that there's a tank here. Why is my tank so slim? Okay, there's a tank here. And then there's they call it a bore. I don't know what a bore is like. I have no idea what a bore is like. B-O-R-E. Bore. And then there's the sudden enlargement. And then there's tank number 2. Why does my tank look like a blob of brick putting together? Tank 2. This is also a bore of 20 millimeter. This is a bore of 60 millimeter in diameter. Okay. Tank 1. Okay, so okay, the water here is elevation of, they don't say anything, and this would be like this, but they will tell us that the difference here, is 3 meters high. There's no additional information. We know that the contraction and this is not the contraction, it's the sudden enlargement. Yeah, there's different names for types of, like, suddenly the diameter changes, like larger or smaller. So now we can start calculating. We can see that there are 5 different sources of pressure loss in the system, and they can express as fluid resistance. So in the resistance in pipe A, A is the smaller pipe and B is the bigger pipe. A, this is a B. So we can say that resistance in pipe A, R1 equals to, can you guys remember that? 32 CFL or G D A5 pi squared. You can check with my formula paper. I'll also check with it as well in case there's some mistakes. It's always, I always likely to have some mistakes during those kind of work. Okay, so let me check this one. Yes, it's, oh, it's not. No, yes, no, yes. It's 32 F prime L, and then there's the Q here, right? So imagine there's no Q here yet. So say F is the F prime, which is the friction factor. Should I just write in what I have written in the paper so that you won't get confused? Okay, F prime. And then let's substitute all the numbers that we need to substitute. 32 times with 0.005. Oh, did I tell you this one? Yeah. The friction factor equals to 0.005. Two zeros. Times with 2G 9.81 times with D, which is this number. How do we do that? 0.002? 0. Oh, only 1 0. 5 times with pi square. So this will be the resistance in pipe number 1. Okay, you might have asked, why did I use this formula that I've shown? Because we're not trying to find the minor head loss. This is only for the minor head loss and the pressure head loss, but this is the pipe, well, the head loss in the pipe. So we're going to use the formula that we use for the Darcy or Hazen, like those big formulas and those big theories. 9.81 times with 0.02 power 5, and then times with pi square. Oh, it's a very large number. 103,2,835 point. Okay, so I will cut down 1, 2, 3, 4, 5, 6. 1 point 10 to the power of 6. The unit is in, yep. I only say yep. Okay, so now we can move on to the resistance in pipe B. Resistance in pipe B. So in this pipe B, you can write R2 because we will be told that, oh, not be told, we can say that there's 5 different sources of pressure loss. The first pressure loss that we can see is pressure loss in pipe A, and then pressure loss in pipe B, and then we have the pressure loss at a sudden enlargement, and the loss at exit, and then there's loss at entry. Yeah, entry. Okay, so 1, 2, 3, 4, 5. So you can see all the pressure loss in all those things. And if you can see that there's the pressure drop, 1, entry, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And then in pipe A and pipe B, pipe this and pipe this. See, there's a lot. That's why I'm doing it the last. I'm not doing before this one. Should I separate it into 2 videos because I don't think I can finish in this video? Okay, R2 equals to the same because it's the formula for the pipe. G dB square pi square. 32 pipe is from the same material, so the friction factor is also the same, but length is not the same. Or length is the same. Oh yeah, it's the same. Why did I say that the length is the same? Because in the diagram it does not show what it says. Each pipe is 2 meters long. Okay. I'm missing information. Sorry. Can you imagine that? Sorry. From a K-drama. 9.81 times with 0.005 0.06 because it's 60 millimeters. Okay, I'll say the length is equal to 2 meter each. 5 times with pi square. The answer is, oh, that's great. I just only need to change the d here in my calculator. 6. Very nice. Oh? Why the numbers are going down so quick? 4250.3527. I'm sorry, I forgot to turn off my notification. As you guys have known, I have finally deactivated my Instagram account because it's been giving me so much of a headache. Not you guys who are watching my videos. You're so lovely, but there are some other people that I don't want to see in the... Yeah, I don't want to see it, so I just can't help myself. Okay, so now let's move on to the third one. It's the last entry. Can you remember which formula are we going to use? Okay, good. That's good. That's right. Very good. I forgot my own formula. Not my own. It's not my formula. 8k Oh, okay. Okay. It's not related. 8k. Do we need to add this in? I don't think our professor is going to give us some kind of this kind of exercise. It's not really easy, but we haven't learned in class, or we have learned it. I'm not sure. I think those kind of pumps are the one that the teacher is going to definitely appear on the exam. Like those kind of pumps here, and then HD, H stat, something like that, and especially the flow design, the gutter, and RH, as well as the Manning's equation. This is, I'm pretty sure, that was going to appear, but I'm not sure if this kind of exercise is going to appear. It was actually on the first week of the lecture, but yeah, I'm not positive. I mean, I'm not positive. I mean, I'm not sure. I'm not positive. Does that make sense? Yeah, okay. Okay, so now we have A for... Why is it A? Because the entry is in pipe A. 8K, okay. K for entry is 0.3. 0.3. And then we have 9.81 times with pi. Yeah, I'm right. Pi square times with A is 0.02 square. The answer is... I think I've been yawning already. Sorry for being a little bit rude. 61. Oh, that's a lot. 61? Oh, wait. It's supposed to be 4. Power 4, don't forget, guys. Don't be like Nate. Why is the number so large? It is too large for me. It's not the same. It's large. It's not the same. It's I don't know if it appears the same as your calculator or not. I got 154,000. Okay, I don't care anymore. Wait, that's too much. I don't think it's the same. Okay, let me do it again. 8 times with 0.3 times with 9.81 times with pi square times with 0.02 power 4. Okay, I don't care anymore. It says this number on my calculator. What happens if it's in an exam? And I get this number that is different from other people because it's my calculator. Huh? What's going to happen? Who's going to take responsibility for me? Okay. I have not because I haven't had much sleep lately. I had too much sleep lately, and that's the reason that I'm being a little bit crazy. Yeah, I can say that I'm crazy right now. I'm not in the right state of mind, so don't mind me. Today's episode will be really fast because yeah, I'm not in the right state of mind. Just kidding. Oh my god, what's going on? That's why I don't want to record when I'm like nighttime. I feels like a radio narrator that's talking alone without any what do we call it? Any participants calling in the line to talk with me. Am I using the right terms? Okay, so this is quite different because for the sudden enlargement, we have another formula for us to define the k. Is for k here, it's already given. It's a fact that is given, but this one is not a fact. We need to find it. But some of them already. Some what do we call that? Some of the Google, some 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 of the exercise they already gave us. For example, in the exam, they already gave us this k, 60. Everything here. No. Square. This one like this. Square. Okay, it's actually dA over dB. Enter over enter over exit. And then square again. 0.79. Okay, so now we can compute the R resistance, R4. It's equal to 8k G pi D4. It's still A. No matter what, it's still A, even if it's already contracted. Why am I saying contracted? If it's already passed through the contraction of the pipe, we still use the diameter of A. I think I better come back tomorrow and talk about it again. I've been talking back and forth. Like, yeah, I'm sorry if you don't understand this episode. Take a deep breath and then let it go. D4 is actually dA, 0.02 power 4. Yes, I got it right this time. I'm not writing to the power of 2 anymore. 9.81 times with pi square. Huh? Pi. Give me pi. Square times with 0.02 power 4. Wow. Fascinating. Okay, so then we can continue to R5, which is the exit. We know that the exit decay is 1. Exit is 1. Wait, I forgot to show you what's the main question. Volume flow rate. they're not asking for the pressure drop. It has nothing related to the previous exercise. Okay, let's forget it. Exit head loss. R5 already, right? R5 equals to 8. I don't want to write the formula again, it's the same, but this one is different. It's B. Well, I have a question. Can you guys answer me? What if there's a bend here? Suddenly the water flows and there's a bend. Or there's a bend like this. Well, the bend becomes here or here. Of course, it's in this pipe. Yeah, we're using dB if there's a bend. K is equal to 9.81 times with pi square times with dB 0.06 square. Answer? Calculator. Oh, I'm so glad I don't need to change anything this one. And then the number will come back so strange you can hate it. Why do I keep getting different number? Is always. I'll trust my calculator. Is G really the gravity? Wait a second. I need to declare. I need to clarify something. Because the answer sheet is giving me different answers, and I wonder what they use for G. Why is G only? Why is it only 0.981? They're using 0.981 for G. If there's anyone who knows what happened with this, please let me know. I really have no idea why they use it. Or maybe I'm pretty sure there's a reason why they're using 0.981 instead of 9.81. 407.7 divided by 8 times with 0.79. Yeah, the answer is the same, but it keeps getting freakier and freakier divided by the answer. And for this answer, they use 9816. You know, like, it's this one and 0.981. This and this is similar to this one, but the decimals are different. You got what I mean? So I'll stick with G equals to 9.81 meter per square second. And if you guys know any answer, please update me. I don't know how as well. R1Q square plus R2Q square plus, this is the reason why I'm recalculating every time I write for you guys, so I'm afraid it will get different. In this case, for our exam, we're not going to find Q because the Q is already given, and as you can see that the Q is always the same, no matter where, how it has been through the pipe. So we can write it as this. Is it raining? Shit is, oh no, I mean it's raining. It would be great if we have some kind of, something crunchy to crunch on. Okay, so I'll plus all of these together. this, this, this. I'm not going to rewrite it again. I'm just going to calculate here in the air. 103285.715 plus with 4250.3527 plus 154925.3573 plus 4079. Guys, please help me. How much is this? Wait, that's right. 5. Okay, it's 2 more 0 plus 6375.529. The answer is 1.606 times 10 to the power of 6 Q, whereas in the exercise here they gave us 1.101, so I don't think that's much difference. It's only a 0.5 difference. Well, that's a lot, guys. It's really putrid. You know, I'm scared of rain. I'm not really like scared, but I don't like heavy rains. I don't think I can sleep tonight. Okay, so I'll just keep you company and you will just keep me company in this show. We then can continue to apply the Bernoulli equation between the free surface of 1 and 2. So where's the free surface? It is this free surface and this free surface. So according to this free surface, we can, okay, so free surface contributes to Bernoulli. And this Bernoulli, we can have h1 plus z1 plus u1 velocity over 2g equals to h2 plus z2 plus u2 plus 2g plus hl. On the free surface of the velocity are small, so we can say that z1 minus z2 equals to hl, the total loss, which is 3 meters. So here 3 equals to 1.106 times 10 to the power of 6. You might have want to ask, where are these? It's gone. Only these are left. Gone, 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 gone. The answer is wait, what is the right answer? 2.7124 times 10 to the power of 6. And then we can where the square root for this one. Where's the square root? Okay. I got 1646.96. Oh, it's 1646.96. What a great number. Meter cube per second. Now the values are the same as in the answer sheet. I am so ngong right now. Because in the answer sheet they wrote it as 65. You know, you can round it up as 65, right? So times 10 to the power of 3 meter cube per second. Don't worry what path you have walked through. In the end, you will get the right answer. Yay! Clap your hands. It's been 45 minutes for one question. For my point of view, I actually wanted to do the other exercise first, because in this case, I mean this one, this exercise, I mean in the next video I want to do this exercise first because it's talking about the flow rate, whereas this one they're asking for the pressure drop. Actually the pressure drop is like, it is similar to head loss. Yeah, pressure drop is like pressure loss similar to head loss. I've done through this case already, so don't worry, we can just continue, but this has the most similar. Okay, so basically we will calculate the minor loss in the pipe first. We can see that there's the entrance, one, 2, 3, 4, 5. See, there's 5. There's no contraction, there's no sudden enlargement, and then we have this z, delta z is equal to 6.5 meter because the surface in this open surface. I think this 2 is just, don't worry about this 2. Yeah, 50, 0.05, near to the 5/4, so everything is the same. I wonder what is this for. Oh my god, please help me. Yeah, I'll just stick to this method. I think there's other method in finding this, but let's just stick to this one. I think this is the easiest method ever. Yeah, we somehow need to use this one and this one if we need to find the pressure. So that's why they gave us a G, and for the Bernoulli equation, we need like P or something like this, right? So that's why they gave us this one. But oh yeah, we need the atmospheric pressure here because the if this one and this one are two tanks, we can cancel out the P, but this one we cannot cancel out because the atmospheric pressure of the pond compared to the atmospheric pressure in the tank, of course the pond is much bigger, so we can cancel this one, but we cannot cancel this one. It's 1.015. Oh, 3 and 2.5. They gave us the V and they gave us this one. Yeah, so we can do it. I will end the show today, right now, because it's raining. Then we can continue, hopefully, tomorrow morning before we meet up. Yes, take care, guys. Be safe. Bye bye.